In this video, you will learn how to write perpendicular equations that go through a specific point on a graph. So far, you probably have already learned how to write a parallel equation through a certain point on the graph. When you are looking for a perpendicular equation, you're really using the same strategies to do it. The only thing that changes is that now you need a perpendicular slope instead of a parallel slope. Otherwise, the methods are exactly the same. So if I'm using the slope-intercept method, which is one of the ways that you can do it, I'm looking for a perpendicular line that is, or a line that's perpendicular to y equals 2x plus 4 and goes through the point negative 4, 6. So the only thing that changes really is that I know that I have to be perpendicular to 2. My perpendicular slope is always the opposite sign. So if it's positive, it's going to be negative, and then it's going to be the reciprocal. So the opposite reciprocal to 2 is negative 1/2. So now I'm just going to plug it in. 6 is my y coordinate, negative 1/2 is my perpendicular slope, and then negative 4 is my x coordinate. And then I'm just going through the steps that we learned about previously. Negative 1/2 times negative 4 is going to be a positive 2. Subtract 2 to zero that out, and I get a y-intercept of 4. So my perpendicular slope was negative 1/2, and my y-intercept I found was 4. So y equals negative 1/2x plus 4. Once again, you can still use the point slope formula. So if I would have used that way, it would have been y minus 6 equals my perpendicular slope to 2 is opposite sign and the reciprocal, x plus 4, because it would have been x minus a negative 4. Go through the same process. I'm going to distribute negative 1/2 times x. Negative 1/2 times positive 4 is negative 2. And then I'm going to add 6 to both sides. So that's going to give me y equals negative 1/2x plus 4. Same answer as I got using the slope-intercept form. Since you've already done some work with the parallel lines, why don't you go ahead and try this one on your own first. Just remember you're going to need a perpendicular slope to the line that you were given, and then you can use either method, the slope-intercept or the point slope. So pause the video, try it using one of the methods, and then turn it back on to see how you did. Either way, if I use the slope-intercept method, which is what I did in blue, or the point slope form, which is what I did in green, I got the same answer, y equals 4x minus 15. So the one thing you just needed to make sure is that if I had a slope of negative 1/4, the perpendicular slope is going to be the opposite sign, so it was negative, so it's positive, and then the reciprocal of 1/4 is 4. So that's really the only difference between what we did with parallel equations and now what we're doing with perpendicular equations. Once again, try this one on your own using one of the methods, and then once you have finished, turn the video back on and check to see how you did. Be careful on this one and make sure you look to see which number is the slope and which one is, so in the original equation here, in the original equation right here, be careful when you're picking out which one the slope is. So here's how you would have done this problem using either of the methods. Right here is the slope. You got to be careful because this one's kind of turned around. So the minus 5x, the number in front of the x is always the slope. So I have a negative 5 for my slope. So my perpendicular slope is going to be the opposite sign. So since this is negative, this is positive. And then my reciprocal of 5 is 1/5. This one is a little bit trickier just because when I do go and I multiply 1/5 times 4, I get a fraction, which is 4/5, which makes it a little bit messier. I suppose you could have also changed that to a decimal because 4/5 is a pretty nice decimal of 0.8. I left it as a fraction and I got 1 and 1/5. Or I suppose if you had it as 6/5, that would be okay as well. So either way, I'm going to end up with the equation y equals 1/5 x plus 1 and 1/5. Final problem here, remember sometimes you're just given the graph instead of the information in a sentence. So in order to figure this out, I'm going to have to know the point. We're given the point it goes through, and I'm going to need to know the slope because I'm going to need a perpendicular slope. So if I look at this orange point, I'd be going 1, 2, 3, so -3 on the x, and then 1, 2, 3, 4, 5, 6 on the y. So the point it's going through is -3, 6. And then if I'm looking at my slope, here are the nice points. So it goes up 1 over 4, up 1 over 4, and we're going positive. So my slope is 1/4. Now the perpendicular slope is going to be the opposite reciprocal. So the opposite reciprocal of 1/4 is going to be a negative, because that one was positive. And then the reciprocal of 1/4 is going to be 4. So I'm going to be using this point and this slope. So if I'm just going to do that quick and put that into, I'm going to use the slope-intercept form. I'd have 6 for my y. I'd have -4 for my slope, -3 for my x. I'm just going to quickly go and solve that. -4 times -3 is 12 plus b. Subtract 12 to zero that out. And I'm get 6 minus 12, it's -6. So my perpendicular equation that goes through that point would be y equals -4 was my perpendicular slope, -4x minus 6. So if I actually went back and did that on the graph, I'd go 1, 2, 3, 1, 2, 3, 4 over 1, 1, 2, 3, 4 over 1, 1, 2, 3, 4 over 1. See how this line that I get here has the y-intercept here of -6, just like we said, and then this right here is forming a right angle. So they're perpendicular lines. The blue and the green one are perpendicular. So now you should also know how to write a perpendicular equation that goes through a given point or a specific point on the graph.